refer to this as my robot, if that's possible. Yeah. So the goal of this robot is to pick up a person on top of a building and put him down on a lower platform. So for this project, I used a total of $90 out of 250, which means it's pretty cost efficient. And with 2 hours and 45 minutes, I spent the first hour brainstorming the ideas for this, and the remaining for buildings and improvising what's going to happen. So my robot is inspired by two designs. One is a crane, and the other one is when I heard about the pick and place mechanism, I immediately thought of a Delta robot configurations, which is pretty much the most common pick and place robot in industrial automation, the fastest as well. So it's just kind of like that. So this robot has 4 degrees of freedom, one extension and retraction over here, and another kind of rotating up and down like that. The 3rd degree of freedom is around here, where it can go up and down here. And the last degree of freedom is here, just picking and placing, and yeah. So for this project, I have a few issues. One is the structural integrity, because everything is made of cardboard and super glue. So for the arm here, I used dowel pins reinforced with cardboard and super glue. And for the joints, I used paper clips. Yeah. Another problem that I encounter is because due to the time limit, it's not actually ready to deploy in real world, because I think the safety factor is a bit low here, where it's 100% that I can actually pick the person up. And the first plan was to make this and kind of slide around here, but due to the time limit, I just kind of improvise and just extend and retract the whole arm instead of the 2 0 here. Any questions?
You'd be able to operate that by yourself?
I'll need one more person, because in actuality, we would have electric actuators here around here to do that, and one person can just, because the wires we all focus in here, and a person can just sit in here and kind of like a crane, just kind of maneuver it. But yeah, for this I'll need assistance. Yeah. Next questions?
So you said 6 degrees of freedom?
4.
4.
Yeah.
Is there any reason that you needed 4? Like, would you be able to do this with less? Like, why 4 specifically?
So I didn't choose to have 4 because of the time limit. I just like ran on whichever ideas I have, and in the end I have 4 degrees of freedom. But I guess it could have happened with just three degree of freedoms. This arm extend, retract, and rotate that way, and another degree of freedom for the grip. So yeah, it's not optimized, but I can optimize it with more time. Next questions?
Being standalone, do you have any issues with time management?
For sure, yeah. But I chose to be by myself because I want just some additional challenge. But with additional teammates, I could have improved the complexity of the design, the structural integrity, and safety factor, and make it more ready to be deployed in real world.
I can't really tell from here, but what's applying the pressure on your closing mechanism?
Just a rubber band. Yeah, here. And I can just open it.
Oh, I see.
And then it automatically closes.
Timer starts with 5, 4, 3, 2, 1.
That's 1 minute. 4. Yeah.
So fast, kid.